Hello students, I hope you might have enjoyed the Pongal holidays. Before we start the chapter number 5, the periodic classification of elements, let us have it in our mind the safety rules. That is, wear the mask whenever you are going out, keep up the distance wherever and whenever you are going out, use the sanitizers often, go out if it is essential or otherwise, be safe in your home. Periodic classification of elements. Introduction. Before the beginning of 18th century, only about 30 elements were known, and it was quite easy to study and remember their individual properties. However, the situation became difficult with the discovery of large number of elements in the later years. At this stage, the scientists felt the need of some simple method to facilitate the study of properties of various elements and their compounds. After numerous attempts, the scientists were ultimately successful in arranging the elements in such a way so that similar elements were grouped together and different elements were separated. This arrangement of elements is known as classification of elements, and it led to the formulation of periodic table. Thus, periodic table may be defined as the table giving arrangement of all the known elements according to their properties so that similar elements fall within the same vertical column and dissimilar elements are separated. Classification of elements. The arranging of elements into different groups on the basis of the similarities in their properties is called classification of elements. The classification of similar elements into groups makes the study of elements easier. There are about 114 different elements known so far. Early attempts at classification of elements. The earliest attempt to classify elements was grouping the known elements, that is about 30 elements, into groups called metals and non-metals. The defect in this classification was that it had no place for metalloids, that is, elements which have properties of both metals and non-metals, which were discovered later. The scientist called Dobereiner made an attempt to classify the elements. Dobereiner's Triads. Dobereiner classified elements in the increasing order of their atomic masses into groups of 3 elements called triads. In each triad, the atomic mass of the middle element was approximately equal to the average atomic mass of the other 2 elements. Look at the table. Here, 3 triads are given. In the first triad, Li, Na and K, that is lithium, sodium and potassium. Sodium's Na's mass is equal to the average atomic mass of Li and K, that is 6.9 plus 39 divided by 2 is approximately equal to the mass of sodium. I hope you might have understood. What is the drawback of this triad? The defect in this classification was that all the known elements could not be correctly arranged into triads. A scientist called Newlands made an attempt in arranging the elements or classifying the elements. It is called Newlands Law of octaves. John Newland, an English scientist, arranged the elements in the order of increasing atomic masses and called it the law of octaves. It is known as Newlands Law of octaves. What are the characteristics of Newlands Law of octaves? It contains the elements from hydrogen to thorium. Look at the table. Properties of every eighth element were similar to that of the first element. Look at the table here. If you are considering Li, lithium, as the first element, then the eighth element will be Na, sodium. These have similar properties. Similarly, if you are considering beryllium, Be, as the first element, then eighth element is magnesium, which have similar in their property. Limitations or demerits of Newlands Law of octaves. The law was applicable to elements up to calcium, which is having the atomic mass 40 only. It contained only 56 elements. Further, it was assumed by Newlands that only 56 elements existed in nature and no more elements would be discovered in the future. In order to fit elements into the table, Newlands adjusted two elements in the same slab and also put some unlike elements under the same node. For example, cobalt and nickel, Co and Na, are in the same slot, and these are placed in the same column as fluorine, chlorine and bromine, that is F, Cl and Br, which have very different properties than these elements. Iron, which is placed in the last column, which resembles cobalt and nickel, Co and Na in properties, has been placed differently away from these elements.